Hello, grade 8. This is Mrs. Lopez, and we are starting on our lesson 1 in module 1. Today we are talking about exponential notation or exponents. It's very weird that we are already dealt with exponents in our volume section, but at the same time, it is important that we know what exponents are and how we use them. So, exponents are is a number that shows what the base number is multiplied by itself and how many times. So when we have, let's say, 2 to the 6th power, we know that 2 is the base number and 6 is the exponent. And 6 shows us how many times 2 can be multiplied by itself. So it's 2 times 2 times 2 times 2 times 2 times 2, and that is 6 times. 6 times. Okay, so here's our very important information. 5 to the 6th means we are multiplying 5 by itself 6 times. 9/7 to the 4th power means that we are multiplying 9/7 by itself 4 times. Notice that 9/7 is in parentheses. That means that I'm multiplying 9 by itself 4 times and 7 by itself 4 times. If I had written it down as 9/7 to the 4th power, that would mean that I'm just taking 9 to the 4th power and not the 7th. So that's not what you want to do. You want to put 9/7 in parentheses to know that we are multiplying 9/7 as a fraction by itself 4 times. If you have seen this kind of notation before, that's good, and it will be a lot easier for you. It is called exponential notation when we are using exponents. In general, for any number x and any positive integer n, x to the nth power is going to mean that we are multiplying x by itself n times. The number x to the nth is called x raised to the nth power, where n is the exponent of x in xn, and x is the base. So just like I said, 2 is the base here, which is our x, and 6 is the exponent, which is our n. We are saying 2 to the 6th power, x to the nth power. Our examples: 5 to the 6th is 5 taken by itself 6 times. 9/7 taken by itself 4 times, it's 9/7 to the 4th power. 9/7 is taken in parentheses. Then we have example 3, -4/11 to the 3rd power. Again, make sure you have the parentheses over -4/11 to make sure that we're taking the whole number as a fraction and multiplying by itself the number of times that there is an exponent. And -2 to the 6th power, again, make sure you have parentheses around -2. And we are multiplying it by itself 6 times. So this is 6 times, this is 4 times, this is 6 times, and this is 3 times. What would happen if I wrote -2 to the 6th power? That would mean that I'm leaving the negative, and then I'm going to multiply 2 by itself 6 times, and that is going to be a different number, right? 2 times 2 times 2 times 2 times 2 times 2. That would mean that. Because you want to multiply -2 by itself 6 times as a number -2, it means that we are going to put -2 in parentheses. And that will mean that I'm going to use -2 every single time, okay? All right, so here we go with exercise 1. Very easy exercises here. We have 4 multiplied by itself 7 times. It means that I have 4 raised to the 7th power. If I have 7/2 multiplied by itself 21 times, it means I have 7/2 raised to the 21st power. If I have 3.6 or 3 6/10 raised to the 47th power, it means I multiply it by itself 47 times. Same goes for exercise 4. If I have -13 multiplied by itself 6 times, I have -13 to the sixth power, notice I'm writing negatives and fractions in parentheses. It is that important. Let's continue. So we have exercise 5. Negative 11 and 63/100 taken in parentheses multiplied by itself 34 times makes negative 11 and 63/100 taken in parentheses to the 34th power. Exercise 6, same thing. 12 is multiplied by itself. We need to know how many times. Since it's 12 to the 15th power, we know that 12 is taken by itself 15 times. Exercise 7, negative 5 taken in parentheses multiplied by itself 10 times makes it negative 5 in parentheses to the 10th power. Exercise 8, negative 1/14 multiplied by itself 10 times makes it negative 1/14 written in parentheses because we are taking the entire fraction to the 10th power. X is multiplied by itself 185 times, makes it x to the 185th power. Exercise 10, x is taken by itself, multiplied by itself, and is written as x to the nth power. It means it's taken by itself n times. Exercise 11. So this one is a little bit tricky. It's negative 1 taken by itself 12 times makes it negative 1 to the 12th power. Do you think this product is positive or a negative? And how do you know? So let's break it down. I would hate writing negative 1 12 times, but that's what I'm going to do. So negative 1 times negative 1 times negative 1. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so all these 12 are here. We know by the integer rule, when we multiply a negative number by a negative number, it makes it a positive number, correct? We know that these two will make a positive number. We know that these two is going to make a positive number. These two is going to make a positive number. This product is positive and this product is positive. Now multiplying all these positive integers by itself and the product is positive. So how can I write, without writing it all down 12 times, that the product is going to be positive? So the actual exponent is going to help us out. If we have an exponent as an even number, and even means it's divisible by 2, I have negative number taken by itself even number of times, it means my product is going to be positive. So I'm writing positive product, because the exponent is even. Now let's look at next one. We have negative 1 taken by itself 13 times. So to my drawing here, I'm going to just add negative 1 more, and that'll be negative 13 times. Now let's look. We have negative here. So we have all these positives multiplied by a negative, and that will make a negative product. So from here, we come up to the rule as well. Negative 1 to the odd exponent will give us a negative answer. Not even only negative 1, even any negative number to the power of the odd exponent is going to give us a negative product. So it's going to be a negative product, because the exponent is odd. Because the exponent is odd. Okay, so here comes the next one, number 12. Is it necessary to do all the calculations to determine the sign of the product. Why not? So we just tried with -1. And -1 is easy because any -1 taken by itself 100 times is still going to be 1, right? Here we have -5. Do I need to multiply -5 by itself all these 95 times to find out the sign of the product? No, I don't. I just look at the exponent. My exponent is odd or even. It's 95. It cannot be divisible by 2 without a remainder. So I know it's odd. So that makes the product of -5 to the 95th power negative. So we are writing no, it's not necessary. Right, not necessary. The sign of the product, is negative because the exponent is odd. Now we have -1 8/10 multiplied by itself 122 times, and that makes -1 8/10 to 122nd power. We know that since the exponent can be divisible by 2, we can divide it by 2. It makes it even number of these numbers. So my product is actually going to be positive. I don't need to do all these calculations. So the sign of the product is positive because the exponent is even. Okay. Exercise. Fill in the blanks indicating whether the number is positive or a negative. So we have if n is a positive even number. This is an even number. So will the product be positive or negative? It's going to be positive because the exponent is even. If n is a positive odd number, then the exponent is going to be negative because this one is odd. Exercise 14. Josie says that -15 taken by itself 6 times is -15 to the 6th. Is she correct? To the 6th. Is he correct? And how do you know? Think about it. What did I say about parentheses? Are they important? They are very important. So if -15 taken by itself 6 times and -15 is taken in parentheses here, it means the whole number, -15, is multiplied by itself 6 times. We have to have parentheses here. If we don't put them, it means it's only it's 15 to the 6th power, and the negative side is just on the side. So that can actually, so it makes a totally different answer. So make sure when you have negative numbers or fractions, make sure to put them in the parentheses. You can put any number in the parentheses if you want. If you can just want to make it a habit of putting any number in parentheses, just do that. Okay, number 15, last one here. Rewrite each number in exponential notation using 3 as a base. So 3 is going to be our number written with an exponent. Let's see how we can break that 9 down. We can break the 9 down by multiplying 3 by 3. How many 3's do I have? 2. So I'm going to write 9 as 3 to the 2nd power. Let's look at 81. How can I make 81? Multiplying 9 times 9. And 9 I can make by multiplying 3 by 3. How many 3's do I have? 1, 2, 3, 4. So it's 3 taken by itself 4 times. It makes it 3 to the 4th power. 27. How can I make 27? 9 times 3. 9 I can break down also into 3 times 3. So that'll make 3 to the third power because I have 3 taken by itself 3 times. And the last one, 243. How can I make 243? Let's see. I can break it down. I know that 3 can go into it. And just here on the side, I'm going to divide 243 by 3. 3 goes into 24 8 times. And 24, 0, 3, 1. So I will have 81. And I already know how to break 81 down. 9 and 3 and 3. How many 3s do I have? 1, 2, 3, 4, 5. Like a Christmas tree. 3 to the 5th power. That is the lesson 1. That's it for today. You have a practice set next. Please complete it, and I will see you in class.